Dear students, let's see this question. Here, in the balanced condition, the values of the resistance of the four arms of a wheatstone bridge are as shown in the figure. Here it is a balanced wheatstone bridge. It is a balanced wheatstone bridge. Here, four arms, four resistances are given, and it is as shown in figure. And he is saying that the resistance R3 has a temperature coefficient of 0.0004 per degree centigrade. And again here he is saying that it is R3, it is having some temperature coefficient. Temperature coefficient of 0.0004 per degree centigrade. And then if the temperature R3 is increased by 100 degrees, temperature R3 is increased by 100 degrees, the voltage developed between S and T, voltage S and T, we have to find out the potential difference between S and T will be. He is asking that when temperature of R3 is increased by 100 degrees, what is the potential difference between S and T? Initially it is a balanced Wheatstone bridge. How it is? We know under balanced condition P by Q is equal to R by S. So P by Q and here R by S are same. So it is a balanced condition. But now what happened? Here the temperature of R3 is increased by 100 degrees. So this R3 is increased by 100 degrees temperature. So when the temperature increases, we know the resistance of a conductor is also increases. Then we will see. First we will calculate how much it will increase. Then after that we will try to find out the potential difference between S and T by using or by applying Kirchhoff voltage rule. Let's see. See here we know that temperature coefficient is given. So we can write R3 dash. R3 dash is the resistance at a temperature of 100 degrees. Formula R3 dash can be written as R3 1 plus alpha delta T. This is formula for related to the temperature coefficient. So R3 dash can be written as R3 is given as 300, 1 plus alpha is given as 0.0004, 0.0004, which means I will write 4 into 10 power minus 4 into 0004 0004. I can write 4 into 10 power minus 4, and temperature is raised to how much it is? 100 degrees. So I will write it is 10 power 2. So again R3 can be written as R3 dash can be written as 300 into 1 plus 4 into 10 power minus 2. R3 dash can be written as 300 into 1 plus 0.004. 0.04, sorry, 0.04. So here R3 dash, if we calculate, I will write here R3 dash can be written as 300 into 1.04 multiply, you will get R3 dash is equal to 312 ohms. That means at 100 degrees centigrade, the resistance of R3 becomes 312. Resistance of R3 becomes 312. Now we have to change the value. We have to apply KVL. After that, we have to calculate the potential difference across S and T. See this. I will modify the circuit. Modified circuit. Here it is given as 60 ohm, and here it is 100 ohm, and here initially it is 300. Now it becomes 312. It becomes 312, and here it is 500, and now here it is S and here it is T. We have to calculate potential difference Vs and Vt. Now see, I will arrange this one so that I can able to solve further. See, in order to find out the potential difference, I will apply the loop rule. Loop rule. For that, I am considering this is loop 1, current is I1, and this is loop 2, current is I2. Current is I2. We can apply KVL for loop 1. Loop 1. So I will start from here. I will start from this point. From this point, if I start, minus 3, 1, 2, I1, and here it will be plus 50. I am moving from low potential to high potential. That's why I wrote plus 50. And in this direction, minus 60, I1, which is equal to 0. Which is equal to 0. So I will write is minus 312, this one is 60. So minus 372 I1 plus 50 is equal to 0. So we can write here, we can write 372 I1 can be written as 50. So I1 is equal to 50 by 372. How much we got? I1? I1 is equal to 50 by 372. Similarly, I will apply for the loop 2. So again apply KVL for loop 2. In this direction moving, right? In this direction moving. So I will start from here. I will start from here. In this direction moving. So here it is minus 100 I2, minus 100 I2. I am coming in this direction, minus 500 I2, and again I am moving from low to high, so it will be plus 50, which is equal to 0. And now here this will be 600 minus 600 I2 plus 50 is equal to 0. From that we can able to calculate. From that I will write here 600 I2 is equal to 50. So I2 is equal to 50 by 600. So I got I1 and I2. I got I1 and I2. I want to find out the potential difference between these two. See, now we have to understand clearly. We can start from here. We can calculate like this. We will get the potential difference. We can start from here. We can able to go like this. We can able to get the potential difference. At the same time, this one also can calculate. This one also can calculate. If you go through these wires in these 4 methods, under these 4 methods, you are going to get the same value. But one thing we have to understand, in this loop, current is in this direction I1. Current is I1 in this direction. And in this loop, if you observe, current is exactly opposite I2. So the best easy method is, just I am observing, I will consider this is P, the junction is P. I will calculate the potential difference here, and I will calculate the potential difference here. From the two, I will get the value. Try to understand again. This S, this P. I will calculate the potential difference between the two. I will calculate the potential difference between the two, and finally, I will calculate the potential difference between S and T. Just see. In this one, current is moving in this direction. So absolutely, S is at higher potential. S is at higher potential, and P is lower potential. So I will write Vs minus Vp is equal to 312 I1. Vs minus Vp is equal to 312 I1. Similarly, I will write for loop 2. In loop 2, current is moving from T to P. Current is moving from T to P. If current is moving from T to P, potential at T is greater than the potential at P. Potential at T is greater than potential at P. So we will write here Vt minus Vp is equal to 500 I2. So our intention is to find the value of Vs minus Vt. He is asking potential developed between S and T, which is Vs minus Vt we have to calculate. Vs minus Vt. So we will see here. I will substitute here. I will calculate here Vt So Vt can be written as 500 I2 plus Vp. And I have to calculate actually Vp it is not just wait. See this? I will calculate Vp value. So Vp can be written as Vt minus 500 I2. I will substitute Vp value in this equation. So Vs minus what is Vp? Vt minus is the minus Vt minus of minus plus 500 I2 is equal to 312 I1. So we can write Vs minus Vt is equal to 312 I1 minus 500 I2. And already we know we calculated 312 I1 minus I1 and I2 values are calculated. So we will substitute and we will get the answer. So I will solve here. So Vs minus Vt can be written as Vs minus Vt can be written as see here 312 I1 is how much? 50 by 372. 50 by 372 minus 500. What is I2? I2 is 50 by 600. 50 by 600. Just a substitute the values. Now we have to calculate. So Vs minus Vt is equal to if you calculate this one, if you calculate this one, you will get the right answer. See here, if you write 312 into 50 by 372, you will get 41.93 minus, if you calculate 500 into 50 by 600, you will get 41.66. This one we know how to calculate, right? By using calculator also you can do, but try to do your own in advanced and mains scientific calculators are not allowed. So we have to do our own. So Vs minus Vt can be written as 41.93 minus 41.66. You will get roughly 0.27. It will be the answer. 0.27 is the answer. Here it is asking that potential difference between S and T, it will be 0.27 volt. Clear? Again, it is advanced question 2020, which does not include any difficult concepts. Only here the basic concepts like KVL and potential difference. Generally, we are thinking IIT questions are maybe tougher, but it is not tougher. But we have to think twice and we have to solve. I hope you understood. Thank you.